Hello everyone. Today we will study about current. The flow of charge is called electric current. The electrons carry charge and flow from one place to another. More moving electrons generate more charge. The amount of current flowing from one place to another is determined by amount of charge flowing through it per unit of time as shown in fig 1.11. The unit of current is ampere, symbol capital A. Symbolic representation of current is I, capital I. Mathematically it can be written as capital I is equal to Q upon T, where I is the current and Q is the amount of charge in coulombs and T is the time in seconds. Coulomb is the unit of charge. This is charge diagram, flow of charge through a cross section A. Q is charge and cross section area of wire. Flow of electrons in conductor. In 1 coulomb, charge passes through a point in 1 second. It will produce 1 ampere current. Conventionally, the direction of current flow is taken as opposite to the flow of electrons. Example: calculate the amount of current flowing through a wire when amount of charge is 5 coulombs and the time is 10 seconds. Solution: we will use the relation between the current, charge and time. I is equal to Q upon T. Q is 5 upon 10. So this is 0.5 ampere. Solution: we will use the relation between the current, charge and time. I is equal to Q upon T. 5 upon 10 is equal to 0.5 ampere. Assignment: formula is electric current I is defined as the rate of flow of electric charge I is equal to Q upon T. I is equal to current in ampere A. Capital A. Q is charge in coulombs. T is equal time in seconds. Current consumed by radio. Given charge Q is equal to 120 C. Time T is equal to 1 minute is equal to 1 into 60 seconds. 60 seconds. Calculation: I is equal to 120 upon 60. I is equal to 2 ampere. Current drawn by LED. Charge Q1 is equal to 180 coulomb. Time 2.5 minutes is equal to 2.5 into 60 seconds, 150 seconds. I is equal to 180 coulombs upon 150 seconds. So I is equal to 1.2 ampere. So here are the answers for assignments. What does an electric circuit mean? An electric circuit is a continuous and closed path along which an electric current flows. It is essentially act as a loop that allow electricity to travel from power source, do work like lighting a bulb, and return to the source. A simple circuit typically consists of three main components. A source provides the energy, for example, battery or cell. Conducting wires carry the current, usually copper wires. A load consumes the energy, example, bulb, motor, or resistor. Optional but common. A switch to open or close the circuit. This is a simple circuit, like this is a battery and this is copper wire, switch to close and open circuit, and this is the electricity consumption source, a light bulb. Define the unit of current. The SI unit of electric current is ampere. It is defined as follows: 1 ampere is constituted by the flow of 1 coulomb of charge per second. Mathematically, if I is current, Q is charge, and T is time, 1 ampere is equal to 1 coulomb upon 1 second. Calculate the number of electrons constituting 1 coulomb of charge. Classification of current. Depending upon the movement of electrons, in an electric circuit, current can be classified as direct current DC. Direct current is unidirectional in nature. Movement of electrons takes place only in one direction. This means that current flows only in one direction. DC voltage source like batteries and cells used in wall clock, remote control vehicles, automobile, cell phones, etc. Alternating current AC. Alternating current is a bidirectional in nature. Movement of electrons takes place in two directions. This means that current flows in two directions. AC voltage source like AC generator produce alternating current. Hydel power plants, thermal power plants, etc. are the example of alternating voltage sources. Alternating current is used in ceiling fans, coolers, washing machines, etc. In India, standard AC generating frequency F of alternating current is 50 Hz. Frequency can be defined as the number of cycles in 1 second. Movement from point A to point B represent 1 cycle. Hertz in the unit of frequency. 50 Hz represent 50 cycles in 1 second. This is the amplitude output with slip-ring AC since wave 1 complete cycle. The main difference between AC and DC current in the direction of flow of electron. In alternating current, the movement of electric charge periodically reverse direction. In direct current, the flow of electric charge is only in one direction. The usual waveform of an AC power circuit is a sine wave. In certain applications, different waveforms are used, such as triangular or square waves. Audio and radio signals carried on an electrical wire are example of alternating current. Now again, assignment. Here is the list gadget categorized by power source presented in a table form for your assignment. Comparison of AC versus DC gadgets. Gadget working on alternating current ACs. Gadget working on direct current DCs. Working on AC, refrigerator, air conditioner, washing machine, microwave oven, electric fan, mixer grinder, blender, electric iron, vacuum cleaner, electric heater, dishwasher. This all are same common thing. These all are home appliances and gadgets working on direct current DCs, mobile phone, flashlight, stores, TV, remote control, wall clock, calculator, laptop, smartwatch, wireless mouse, keyboard, digital camera, battery operated toys. These also are home and office appliances, electronic appliances. AC gadgets are typically heavy duty appliances that plug directly into the wall socket mains and require high voltage to operate motors and heaters. DC gadgets are typically portable devices that run on batteries, chemical energy converted to electrical energy. And some devices like laptop and television plug into wall AC but use an adapter like brick on the cord to convert AC into DC because their internal electronic chips actually require DC current to function. However, in most general classification, battery power items are the clearest example of DC gadgets. Resistance. We know that in conducting material, electrons are loosely held and can move easily. In insulators, electrons are tightly bound to their atoms and they do not move easily. A high voltage is required to move the electrons in an insulating material. On the other hand, low voltage is required to move the electrons in any conductor. In conductor, the resistance is low, while in insulator, the resistance is high. Resistance resists the flow of electrons and hence the flow of electric current in the circuit. Conceptually, resistance controls the flow of electric current. Resistance is represented by symbol R, capital R. The SI unit of electrical resistance in ohm. Example, we use various appliances for our daily use at home to control the amount of current flowing into the appliances. Resistors are used. If a resistor is not used in the circuit, then it will cause damage to the appliance. So George Shima Ohm. Electric power. Electric power is the rate at which electric energy is transferred by an electric circuit. Electric power is the rate of doing work, which means amount of work done in 1 second. Power is represented by symbol P, capital P. The SI unit of power is watt, capital W, which is equal to 1 joule per second. It is named after Scottish inventor James Watt from 1736 to 1819. Electric horsepower HP is another unit of measurement of power. It is equal to 746 watt. It is slightly higher than mechanical horsepower, which is 745.7 joule per second. The electric power in watts produced by an electric current I consisting of a charge of q coulomb every t second passing through an electric potential voltage difference of V is qv upon t is equal to V into I, where q is electric charge in coulomb, t is the time in second, I is an electric current in amperes, V is electrical potential or voltage in volts, P is work done per unit time, P is equal to W upon T, or P is equal to 12 R, where W is work done in joules, T is time in second. James Watt. Now power can also be defined in terms of current and voltage. The product of voltage and current results in power. Watt is a measure of energy flow. Since watt is a very small unit of power, in actual practice we need a much larger unit, the kilowatt, which is equal to 1000 watt. Since the product of power and time gives electrical energy, therefore unit of electrical energy is watt hour or kilowatt hour. 1 watt hour of energy is consumed when 1 watt of power is used for 1 hour. The commercial unit of electrical energy is kilowatt hour. LED bulb by Government of India. 1 kilowatt is equal to 1000 watt into 3600 second, 3.6 into 10 raised to power 6 watt second, or suppose power of LED is 9 watt, which means that it will do 9 joules of work in 1 second. Assignment. There are step-to-step solution in your assignment. Calculating of electric power given voltage V 440 volt, current 2 ampere. Formula: power is equal to volt into I, current. Calculation volt P is equal to 440 into 2, 880 volt. Calculate the charge flowing. Given power is equal to 1000 watt, voltage 220 volt, time 10 second. Find the current. I is equal to P on V. I electric current is equal to I is equal to P upon V is equal to 1000 upon 220, that is equal to 4.545 ampere. Find the charge Q. Q is equal to I into T. Q is equal to 4.545 into 10. Q is equal to 445 into 45 C. The amount of charge flowing through the machine is approximately 45.45 coulombs. So the building blocks of electricity, a visual guide. Voltage is the electrical push. The three pillars of electricity: current, the electrical flow; resistance, the electrical friction; voltage, the electrical push, the force motivating electrons to flow in a circuit. Measured in volts. Current, the electrical flow, the continuous movement of electrons, like these are electrons, through a conductor measured in ampere. Resistance, the electrical friction, the opposition of flow of electrons in a circuit measured in ohms. Then Ohm's law. Voltage is equal to I into R. Define the direct relationship between voltage, current and resistance. Series circuit. There are two types of circuit: series circuit, a single path; parallel circuit, a multipath. In series circuit, current is the same through all components. If one part breaks, the circuit fails. In parallel circuit, multiple paths, like voltage is the same across all branches. So if one path breaks, other can still works. More to know, Government of India has launched national program of LED based government street lighting in for energy conservation by reducing energy consumption. Government of India has also launched a scheme for light emitting diode LED bulb distribution under the domestic efficient lighting program DELP. Domestic efficiency lighting program DELP 9 watt LED.